Pluto is a remote and faint, more modest heavenly body that was once a part of the local star system. Nevertheless, recent and startling assertions made by well-known space scientists Michio Kaku and Neil deGrasse Tyson have brought Pluto back to the attention of the public, suggesting that this far-off object may be traveling in a likely... They're not just speculating with Neptune. They are advising that this small world may be heading in a risky direction on a path toward a catastrophic collision with Neptune. But how could that possibly occur, and what would the repercussions be if such a massive event ever occurred? Are we witnessing some kind of bizarre cosmic illusion, or is something significantly more real and terrifying hurtling toward us? Pluto's orbit cuts alarmingly close to the planet Neptune. Neil deGrasse Tyson and Michio Kaku are sounding the alarm that, in the event of anything even remotely catastrophic on the planet, we could be in for a bad outcome. Could Earth be in danger as well? Even more importantly, how feasible is such a cosmic event? Join us as we investigate the ramifications of a Pluto-Neptune impact. Pluto, once classified as a planet, continues to be categorized as a dwarf planet and remains an intriguing topic in the expansive universe, as shown by current theories from experts in the field. Pluto's path is dangerously close to Neptune. Space experts Michio Kaku and Neil deGrasse Tyson are both warning about a possible danger from the coexistence of these two worlds, which might suggest a tremendous risk. Still, how feasible is such a scenario on Earth? Pluto's voyage around the solar star is unique among all others in our planetary system. Surprisingly, it takes 148 Earth years to finish a complete loop. Since its identification in 1930, it has yet to even complete a single cycle, but Pluto's curiosity does not end there. Its trajectory, an extremely long and deviating path, is significantly different from the largely circular revolutions of the principal planets. What intensifies Pluto's extraordinary path is its tilt, which is 17 from the solar plane. Pluto's route traces a significantly more irregular path in contrast to the tilt of other planets' eccentricity, adding layers of complexity to its orbital configuration. Arguably, one of the most intriguing elements of Pluto's orbit is its overlap with Neptune's. For approximately 2 decades in each circuit, Pluto actually becomes nearer to the Sun than Neptune, contrary to what one might anticipate based on their usual placements of the planets. This brings up the common inquiry: why hasn't Pluto collided with Neptune? The reason resides within the effects of the gravity of the planets that surround it. The investigation of Pluto's path began shortly following its revelation. Initially, astronomical researchers tried to comprehend its unique route. In contrast to most other planets, whose loops are relatively aligned with the solar plane, Pluto's route stands out with its sharp angle and uneven layout. With the recognition that the orbit of Pluto indeed connects with Neptune's, despite these irregularities, Pluto's path remains steady, standing as proof of the nuances of cosmic physics. The three-body dilemma in understanding how three cosmic entities, Pluto, Neptune, and the Sun move and affect each other through their gravitational pull is akin to forecasting future alterations based on their initial positions and mutual gravitational tugs. In Pluto's case, this issue demonstrates how the pull of the Sun and the loop of Neptune all operate in an interwoven way. The expressions orbital drift and VZK wobble are essential for solving this mystery, as noted by astrophysics specialists. What ensures that the planets remain in their circular tracks is synchronized oscillation with regard to Neptune and Pluto. This phrase fundamentally means that when Pluto passes through Neptune's orbital path, it is located at a crucial angular separation more than a 90-degree angle away from Neptune, preventing their paths from clashing. Orbital drift, by contrast, refers to the vertical motion of a body as it revolves. This indicates for Pluto that when it gets closest to Neptune or another giant world, it lies significantly above their orbital tracks, adding another level of defense against likely crash. An additional significant aspect of this discussion is the VZK wobble. named for three researchers Kaku, Zeldovich, and Cooper who analyzed the spatial dynamics of cosmic entities. It involves how three planetary masses like Pluto, Neptune, and the Sun exert pull on one another with their mass-based attraction. This influence determines how they move. In Pluto's instance, the VZK wobble provides insight into why its route near the Sun appears so erratic. Despite this, the wobble helps stabilize the movement to maintain a smooth flow across long periods of time. The VZK wobble reveals that, even though the cosmos may look chaotic, strange principles and patterns continue to impose some degree of order. These dynamics assist in sustaining Pluto's steady path, ensuring that it does not collide with Neptune or stray from its regular route. This interaction between the three bodies is crucial to grasping how space trajectories shift due to interjecting forces. Analyzing it teaches us more about Pluto, our planetary group, and even far-off galaxies and their stars. Estimates at the end of the 1980s demonstrated that, despite the fact that Pluto's orbit is strengthened by stabilizing attributes, it remains erratic. Small initial deviations can result in dramatic divergences over the centuries. It has been demonstrated that orbital behaviors astonishingly maintain equilibrium over extensive timelines. Assessing modifications through subsequent automated readings has helped us discover how the enormous planets Neptune, Saturn, and Jupiter contribute to this balance. Neptune has its own unique orbital correlation with Pluto that allows Pluto to make 2 revolutions for every 3 that Neptune completes. This synchronized relationship preserves Pluto's stability. However, Neptune doesn't act alone. Jupiter's immense gravitational pull contributes heavily to keeping Pluto's track stable. Saturn also contributes to the mix. Research reveals that Jupiter's colossal mass is powerful enough to protect Pluto's path from disruption over an extremely lengthy period. It appears that Neptune, Jupiter, and Saturn are all working together to ensure that Pluto's orbit remains steady. Pluto glides securely through the void without running into dangers like these. Strange, yet essential systems play a major role in maintaining cosmic order. Our solar system lacks such mechanics, its neighborhood would be a significantly turbulent realm. Objects like Pluto might be thrown out or collide entirely with other celestial bodies, causing domino effects, particularly with concerns regarding Pluto and its interactions with Neptune in the future. It is essential to comprehend its movement, which offers a sharper image of the vibrant and ever-shifting nature of our planetary system. The example of Pluto's cluster shows how paths that appear unstable can lead to equilibrium through intricate gravitational interactions and kinetics. It also emphasizes the need for constant surveillance and examination of such oddities to better comprehend our place in the cosmos. Frequent, deep exploration of the outer realms forces us to face the bizarre attributes of celestial bodies. Furthermore, Pluto's orbit is a perfect instance of this anomaly. The theory of orbital disorder, which refers to the sensitive dependence on initial orbital data, can be clearly seen here. This suggests that minimal changes in Pluto's speed or coordinates could greatly influence its far future path. Making use of computer-based forecasting has been very advantageous for students working in space to decipher Pluto's actions. These programs use complex equations to simulate how Pluto and other bodies, like Neptune, adjust to gravitational interactions. By analyzing small details in these forecasts, scientists can observe how even slight changes can result in completely different destinations. In the late 1980s, digital models surprisingly revealed that, despite Pluto's stabilizing mechanisms like asynchronous orbital drift and oscillation, if its trajectory continues to behave abnormally, a very small discrepancy in location or velocity could result in a vastly different position in just a few years. Yet, despite this unpredictability, Pluto's trajectory has endured across immense stretches of time, totaling billions of years. This indicates that Pluto's path has an underlying consistency, even though it may appear unruly at first glance. Predicting the orbits of stars, particularly ones as erratic as Pluto's, remains a monumental task. The core unpredictability of these systems results in far-off predictions that are rife with unknowns. Despite the fact that math-based models are outstanding for decoding and estimating the speed of the universe, they also highlight our limits. These formulas depend heavily on starting values, and even the tiniest error or modification can dramatically shift the result, making pinpoint accuracy a real challenge. In addition to their erratic tendencies, planetary pathways, like Pluto's, highlight the constant evolution and flux of the universe. Although humanity has uncovered significant understanding of the stars, the oddities of Pluto serve as a reminder of how much still lurks beneath the surface. How massive planets alter Pluto's movements gives us a broader understanding of the behavior of the solar system. This shows how each planet's location and presence can meaningfully influence the steadiness and direction of others in the structure. So, why are astrophysicists suddenly expressing anxiety about a possible smash-up between Pluto and Neptune, even with all the cosmic laws preventing it? Neil deGrasse Tyson, a well-known figure in space scholarship and a key promoter of cosmic knowledge, delivers a distinct angle on these mysteries. Tyson, recognized for his efforts in demoting Pluto to dwarf planet status, makes it easier to share thoughts regarding the shifting tenets of orbital research and the general public's curiosity about the overlooked regions of the heavens. His stance on Pluto's label change stems from our constantly improving knowledge of the solar neighborhood. He views the shift not as an insult but as a critical correction to our understanding of things that revolve around our star. Tyson's outlook on orbital physics emphasizes continual education and adaptability, interpreting complicated trajectories like Pluto's as a symbol of how much more there is to uncover. The enigmatic nature of such inquiries keeps astronomy thrilling. However, while Tyson remains hopeful, his outlook on a potential Pluto-Neptune collision is far less optimistic. His concerns, rooted in the time when Pluto was a full-fledged planet, are based on his understanding of the unpredictable nature of these orbital dances. He admits that, while Pluto has thus far remained secure, small changes accumulating over time may result in catastrophic events on Pluto's path, particularly in its overlapping zone with Neptune, which forms a complex spatial rhythm that may not remain in sync forever. In the slightest aspect of Tyson's point of view, Pluto's path could be disrupted, resulting in significant repercussions. If these imbalances grow over centuries, they could eventually result in chaos or even a planetary crash, though such an event wouldn't happen in the near future. Instead, it would span incredible lengths of time well beyond the reach of human civilization. Tyson's hesitant tone calls for more vigilance and in-depth research into Pluto's orbital pattern. He isn't standing alone. Michio Kaku, a renowned theoretical physicist, also sees the astronomical upheaval that might result from interactions between planets. Despite the fact that Kaku rivals Tyson's offer the magnificence of the universe, he also recognizes the shaky balance of planetary orbits and the wild, unexpected effects that may occur over time. Tyson and Kaku emphasize the significance of continuous space exploration into the invisible forces dictating planetary drift and the outlook for our starbound family. In the end, Pluto's situation illustrates how our knowledge of the universe is constantly changing. Each breakthrough leads to further intrigue. As space science advances, the possibility of a Pluto-Neptune collision is a humbling reminder of how vast outer space is filled with unexpected turns. Even the peaceful course of a planet can shift significantly over time. These lessons from Pluto serve as a reminder to keep watching the skies and wondering about the buried secrets of the stars.